All right, everybody, let's look at our 11.4 homework. I'm going to do 5 problems with you here. First one right here, actually the directions are pretty much the same for all of them. In this section here, 11.4, we're finally now working on finding the volume of our three-dimensional solids. How much stuff you can fit inside a three-dimensional solid. So let's get working on this. The first thing we have to do on every one of these problems is to recognize what solid it is that we're dealing with. And what we have right here in number 1 sure looks like a prism. I see a shape here that's definitely a rectangle, although as I look at it closer it's 10 by 10, so that rectangle is actually a square on the top of this figure. And it looks like there's another congruent and parallel rectangle on the bottom of this figure. So what we're dealing with here is a rectangular prism, or a little more specifically a square prism. So the formula we need here is one of the easiest formulas we're going to learn all year, everybody. Formula for volume of a prism is capital B times a lowercase h. The capital B means area of the base, and the lowercase h means the height of the prism. So step 2, let's fill in what we know. The area of the base now, capital B, and that base we said is just this square right up here, either on the top or the bottom of the figure. Well, it's a 10 by 10 square, so the area of that base is just going to be 100. And let's talk units like we were before here. When you are multiplying a base here of 10 kilometers by a height of 10 kilometers, kilometers times kilometers is going to get you square kilometers. That's the unit here for area of the base. We're then going to multiply that area of the base now by the height of the prism. And the height of the prism, once again, is defined as the distance between the bases. Well, in this case, since the bases are on the top and the bottom, the height then is that vertical distance in between them. And that's going to be this 6 kilometer measurement right over here. So 6 kilometers is going to be the height. Let's not make the mistake of thinking that base always needs to be on the bottom and height always needs to go up and down, but it does in this case. And in step 3, let's go ahead and put everything together right now. We'd multiply the 100 times 6 and get 600. And just a little explanation of the units. The area of the base was measured in square kilometers. The height was measured in linear kilometers. So we're multiplying square kilometers by linear kilometers. Remember that this exponent, when there's not one listed there, is really a 1, and when you're multiplying here, we add those exponents together. So square kilometers times linear kilometers ends up getting you cubic kilometers, and that is the reason why the units for volume are cubic, and in this case cubic kilometers. Okay, so that one worked out pretty well. Now I do want to say real quick, back in middle school you guys probably learned a formula that looked something like this. Volume is equal to length times width times height, and if you did that here, you might have just said, okay, I've got a 10 here and a 10 here and a 6 here, and if I just multiply those three together, that's going to get me that answer much faster than what we just did right here. You're right, but I have to emphasize here, that formula right here only works when we're talking about rectangular prisms. So as we move on to a problem like number 2, the formula length times width times height is not going to help us here at all. So, what are we dealing with? Well, let's take a look at the shapes that we see. The first thing that stands out to me is that we have a triangle right up here on the top of that figure. And then it looks like we have another triangle that's exactly the same size and facing the same direction down here on the bottom. And sure enough, those triangles are connected by 3 parallel and congruent line segments here, connecting the top and the bottom. This is another prism. Technically, it's a triangular prism, but that doesn't impact us too much for right now. So step 1, we once again need the formula here for volume of a prism, which, just like it was on number 1, is capital B times H. But say the words as many times as you can to yourself. Capital B means area of the base, and H means height of the prism, or distance between the bases. Step 2, this one's going to be a little tougher than the last one. Volume is equal to, we do not know the area of our base, and we do not know our height yet, so let's go ahead and try to figure those out. And this is a little tougher than the last one. Okay, so the base we're dealing with here, guys, again, you can focus on either the top or the bottom here, is a triangle that looks like this. And the sides of that triangle are 6 kilometers and 8 kilometers. And then this long piece over here is parallel to this one, so that's going to have a length of 10. And something pretty important there that I kind of drew over, there's a right angle right here on the bottom of that figure. That means that the top is going to have a right angle here as well. And what we have there in blue is a right triangle. So when we need to find capital B, area of the base, we need to remember the formula here for area of a triangle, which is 1/2 times its base and its height. Now be careful, right here guys, we're talking about the height of the blue triangle. Right here, we're talking about the height of the overall prism. So those are not the same thing. Let's remember that. All right, so back to it now. Capital B then is equal to a 1/2. And here's something worth remembering. That blue triangle up on the top of this figure is a right triangle. And in a right triangle, the two legs are always perpendicular to each other, the 6 here and the 8 here. So those are the two sides that we can use for base and for height because they're perpendicular to each other. They make a right angle. So the 1/2 times the 6 times the 8, 6 times 8 is 48, half of that is 24. So the area of that blue triangle on either the top or the bottom of this figure is 24 square kilometers. So I'm going to put a 24 right there for the area of the base. All right, let's switch to red right now. And as we're going to find height, again, height means distance between the bases. And just like in the last problem we did, although not in all of them, here the bases are on the top and the bottom. So the height of this prism is the vertical distance between them, and that's the 7 kilometers that we get right there. So we know the area of the base, we know the height. Let's go ahead and multiply those together. And let's see, that's a 140 plus a 28 is going to be a 168. Technically, that 24 there again was an area, so that was square kilometers. The 7 was the distance, that's just linear kilometers. And once again, that's going to get us cubic kilometers, which is not a terribly realistic unit there, but that's what it is for number 4. Okay, let's move on to number 7. This one bothers people sometimes. And again, the big thing we have to do on number 7 is figure out what in the world it is that we're actually dealing with here. Well, what do we see here? I see some rectangles, but I think more importantly, I've got a shape right here. Boom, 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 and boom, that really looks to me like a trapezoid. Okay, there's another trapezoid then on the opposite side of the figure, and that trapezoid looks exactly the same as the one that we have over here on the left. And then those two trapezoids are connected by congruent and parallel line segments. What we have here is a funny name, everybody. It's called a trapezoidal prism. I'm trying to think if you have any of these sitting around your house. I've seen some boxes in my life that look like trapezoidal prisms. They're kind of nice because they stack into one another pretty well. Also looks like a mud pan for doing drywall, if anybody's ever seen one of those. But anyway, here we go. So for step 1, once again now, we need the formula for volume of a prism, which is still going to be area of the base multiplied by the height. Little bit of work here to figure all this out. So now the formula for volume of a prism, we don't know area of the base yet, and we don't know the height yet. But finally now, I'm glad this showed up. This is an example of what I've been warning you guys about in the last 2 problems. The base is not always on the bottom. The bases of a prism are the 2 congruent and parallel polygons on opposite sides of the figure. This trapezoid right over here, everybody, is one of our bases. So I'm going to switch to blue here, and we've got to do a little bit of digging off to the side to figure out the area of that base. So again, the base is a trapezoid. So to find capital B, we need to know the formula for area of a trapezoid, which you might have to go look up from chapter 10. I believe section 10.2, and that formula here was a 1/2 times the height times the sum of its 2 bases, base 1 plus base 2. All right, so let's see what we've got. Oh, and a little bit of a reminder now. Within a trapezoid, the bases, base 1 and base 2, are the 2 parallel sides, and the height is the perpendicular distance between those two. Okay, so the 2 parallel sides, there are red arrows there that I kind of drew over here, but the 2 parallel sides are this one right here and this one right down here on the bottom. Now that one on the bottom is pretty clearly 4 yards. This one up here on the top, it's not 10, even though that 10 is near it. Look at what it's parallel to, which is this piece right here. That 6 yards is the second base. And we need height now right here. Height is the perpendicular distance between them. And I kind of drew over it, but there was a line segment right here, and that's the 3.9 yard measurement there. So 3.9 is your height. And the bases are the two parallel sides of 4 and 6. Okay, little messy right there. So capital B then, area of our base is equal to, and let's do this together on the calculator, everybody. We had a 1/2 multiplied by your height, which was, I believe, 3.9. Oops, sorry. Here we go, 3.9. And then that got multiplied by, in parentheses, the sum of our two bases, which was 4 plus 6, and that gets us 19.5 for the area just of those trapezoids on the left and the right. 19.5. So that's capital B, everybody. That's what we were looking for right there, 19.5. This last part is usually pretty easy once you identify it properly. A lot of people are going to tell me that 3.9 is the height because they make the mistake of thinking that height always needs to go up and down. It does not. So again, everybody, let me erase everything else that's going on here. The definition of height in a prism is distance between the bases. And if your bases are on the left and the right, then your height is this distance right here that runs between those two trapezoids. And that 10-yard measurement right there, that's the height of this prism. Again, remember guys, height doesn't necessarily mean up and down. Height means distance between the bases. And if you can force yourself to memorize that phrase, height means distance between the bases. And if you can properly identify where the bases are, that's going to help you out a lot. Okay, speaking of some help here, we got a little break here. All we had to do was multiply 19.5 times 10, so we just slide that decimal 1 to the right, and we end up with a nice clean answer of 195. All the linear measurements here were yards, so our volume units are going to be in cubic yards. Okay, that is number 7. 2 more problems I wanted to do with you. 9, 10, 11, and 12 on the worksheet are a little bit goofy, so I certainly wanted to do one of those with you. First thing we need to do is, once again, recognize what kind of shape we're dealing with. And as we look at it here, guys, there is a pentagon up on the top of this figure and another congruent and parallel pentagon on the bottom. Once again, this is a prism. And just like the last 3 problems, the formula for volume of a prism doesn't change. Area of the base times the height. But figuring out the area of that base is pretty tough to do in a pentagon, so that's why I wanted to walk through this one with you. So, capital B, I'll do this up to the side right here. We need the area of our base, and our base is a regular pentagon. So let's go back to this formula. Area of a regular polygon, which we learned in section 10.3 and did more with in section 10.5. That formula now is 1/2 times the perimeter times the apothem of your polygon. Okay, so let's see what we can do with that. All right, so B is 1/2 times, okay, and the P means perimeter of this pentagon. Well, as we look at it, there are tick marks there that show us that all 5 sides of that pentagon are congruent, and each one of those sides has a length of 6 kilometers. So, we'll probably do this in our heads, guys. 5 times 6 is going to give us a perimeter of 30 kilometers. And the apothem is given to us, everybody. That's the distance or the length of a line segment that goes from the center of a pentagon perpendicular to one side. Well, they drew it right down here on the bottom and told us that the apothem then was 4.1 kilometers. Okay, so those are the 2 things that we needed. So let's plug that into the calculator. 1/2 times 30 times 4.1. And that is going to get us 61.5 just for the area of one of the pentagons. 61.5. So that is capital B right here. This is the importance of labeling your work, everybody, so you can see very clearly what it is that you found and what you need to do with it. The second thing we need now is the height of the prism. And remember, height doesn't always mean up and down, but it means distance between the bases. Well, we lucked out here, guys, because the pentagons are on the top and the bottom of this figure. The height is the vertical measurement, and that's a 7-kilometer side right there. Okay, so we know the area of our base, we know the height, so let's go ahead and plug that in, 61.5, which is my last answer here, and I just need to multiply that by 7 and get 430.5 for our answer here. 430.5. Again, kilometers are going to get us cubic kilometers for the units of volume here in problem number 9. Okay, so 10 I think is another pentagonal prism, and I believe that 11 and 12 were hexagonal prisms. The only difference in a hexagon is that for perimeter you're going to multiply your side length by 6 rather than by 5. And the last one I wanted to do with you, we were also talking about volumes of cylinders in this section right here, and that's what's going on in number 13. I see a circle on the top of this figure. I see a congruent and parallel circle on the bottom. That really should be a dotted line right there, connected by 2 congruent and parallel line segments. So yeah, this is a cylinder. You've got these in your kitchen, I'm sure, right now, guys. A can of soup, jars of spices, stuff like that. So you got a lot of those lying around. Okay, so our formula for volume of a cylinder looks more complicated than what we were dealing with earlier. It's pi r squared, and if I stop right there, you should recognize what that is. And then there's an h that gets multiplied as well. Well, I hate to keep doing this to you guys, but we were just dealing with this formula here for volume of a prism on the last 4 problems. Area of the base times the height. Well, I want you to notice that these 2 formulas end the same way. They both have an h, but the formula for volume of a prism has a capital B, and the cylinder formula replaces that B with a pi r squared. I'm hoping that makes sense. The capital B means area of the base, and the base in any cylinder is always a circle, and the formula for area of a circle is always pi r squared. So even though these formulas look different, they're really the exact same formula here. All right, let me get rid of some junk here we don't need, and let's get working on this. Okay, step 2, volume of a cylinder is equal to pi times, we need our radius squared, and we need to multiply that by our height. Well, as we look at it here, guys, they didn't really give us a radius, but they did give us the distance from the left edge to the right edge of that circle was 6 centimeters. That 6 centimeters is your diameter. And if your diameter is 6 centimeters, your radius is always going to be half of that, which is 3. So the radius is 3. Don't forget to square that. And the height of this cylinder is the distance between the 2 bases. And in this case, although not always, that is the vertical distance right here of 6. So the directions here said to leave your answer in terms of pi when possible. So what's going on right here? Remembering, please excuse my dear Aunt Sally, we would do exponents first. So the 3 squared is going to get you a 9. The 9 multiplies by that 6 right there to make 54. And then the pi just goes along for the ride here, so 54 pi. And when linear units were in centimeters, we now have cubic centimeters for our units for volume. That's probably the first realistic units for volume we've come up with in the last 5 problems. All right, guys, so that is 5 of the 16 problems there on the 11.4 worksheet. I think you're going to be able to get the other 11 on your own just watching with these ones here. So make sure you're showing all your steps, correctly identifying what it is that you're dealing with, knowing where your bases are and what direction your height is going. Good luck. Let me know if you guys have questions.